deadbeat controller. It is a digital controller. So now we will come to that deadbeat controller. Deadbeat controller. The deadbeat controller is the assumption we made is we are designing a controller for set point change. That is y set point of z s equal to 1 by s. Y set point of s equal to 1 by s. For that, we are going to design a controller. We are going to give a set point change. For that, the controller should work. For that, we are going to design. Therefore, y set point of s equal to 1 by s. Therefore, y set point of z equal to 1 by 1 minus z power minus 1. If you take z transform for 1 by s, you will get 1 by 1 minus z power minus 1. These and all you have to memorize. We know the set point. Suppose I am giving step input to the system. This is the system. This is the system. I am giving y set point of s equal to 1 by s. I am giving a digital controller is there. D of z is there. A zero order hold is there. Then a process is there. Process is 1 by 3s plus 1. For that, I have to find d of z. Here also one sampler is there. Here, what is y of z? I am expecting that if I give a step input like this, in digital, how it appears, this is 1 by s. What is 1 by 1 minus z power minus 1? If you plot, it will be like this. This is the step input. 1 by 1 minus z power minus 1. Digital step. That is given. If this is given, I am expecting a response of like this. I am expecting a response like this. What is the meaning? This is first sampling period. This is first sampling period. This is second sampling period. Zeroth sampling period. Third sampling period. If I give at 0th instant, if I give a step change, the process output will be like this. This is the assumption we made while designing the deadbeat controller. The input is like this. Here, the input is like this. At 0th instant, the output is like this. The output is like this. After one sampling period, I am getting the response. That is the assumption we made. Why one sampling period delay? We cannot expect at the same time. That's why we are giving one sampling period delay. We can expect after one sampling period because it has to pass through all these blocks. That's why it has to pass through the process. Process has the time constant. That's why we can expect at least after one sampling period. So after one sampling period, the response is like step input. Therefore, what is the y of s? Y of s is 1 by s. It is also step, but not 1 by s. Delayed s. Delay how much? One sampling period. That's why e power minus ts by s. This is in s domain. What is in z domain? For a step, y of z equal to 1 by 1 minus z power minus 1. This is the z domain step signal 1 by 1 minus z power minus 1. A delay is that delay by one sampling period. That's why we have to multiply by z power minus 1. That's all. So y of z is equal to one step signal, but delay by one sampling period. Suppose two sampling period delay means z power minus 2. Three sampling period means z power minus 3. Here we are assuming that the response is available after one sampling period. The response is available after one sampling period. Therefore, z power minus 1 upon 1 minus z power minus 1. So here, what is y of z by y of z. Therefore, the transfer function output by input equal to what? Output is z power minus 1 upon 1 minus z power minus 1. Input is 1 by 1 minus z power minus 1. These two getting cancelled. That is equal to z power minus 1. Z power minus 1. Therefore, y of z by y set point of z equal to, what is the response we are expecting? A step output is expecting, but a delay by one sampling period. What is the input we are giving? Step input, that is 1 by 1 minus z power minus 1. So the denominator getting cancelled, therefore z power minus 1. So now we can find the digital controller. What is digital controller? D of z equal to 1 by hgp of z multiplied by y of z by y set point of z whole divided by 1 minus y of z divided by y set point of z. So y of z by y set point of z is z power minus 1. Therefore, the controller is 1 by hgp of z power minus 1 divided by 1 minus z power minus 1. That's all. If you know hgp of z, you can find the controller. So if you find hgp of z, you can find the controller. Let us assume that g of s equal to 1 by 3s plus 1. This is g of s. Let us assume. What is hold circuit? Transfer function of hold circuit is h of s equal to 1 minus e power minus ts upon s. T equal to 1, sampling period equal to 1. Therefore, 1 minus e power minus s upon s. Therefore, hgp of s, this is gp, process transfer function. hgp of s equal to 1 minus e power minus s ts, sampling period is 1 upon s multiplied by transfer function is 1 by 3s plus 1. Any delay, if you find the transfer function is in z domain, if you convert this into z domain, you will get z power minus 1. That's all. E power minus s equal to z power minus 1 if sampling period is 1. Therefore, what is hgp of z? hgp of z, because to find a digital controller, you need hgp of z. So we have to convert this s domain to z domain. Therefore, 1 minus z power minus 1 for the numerator and z transform of 1 upon s multiplied by 3s plus 1 that you got. So we have to find the z transform of 1 upon s multiplied by 3s plus 1. That is hgp of z. That is hgp of z. So that the standard formula is available. That is z transform of 1 by s multiplied by tau s plus 1 equal to 1 by tau 1 minus e power 1 by tau t by tau actually. T is sampling period. Here sampling period equal to 1. Therefore, e power 1 by t z power minus 1 upon 1 minus z power minus 1 multiplied by 1 minus e power minus 1 by t by tau. T equal to 1. Z power minus 1. This is the formula. This is, let us put this as tau. Tau. This is tau. This is tau. Sampling period equal to t. Therefore, t by tau. T by tau. Here also t by tau. T equal to 1. That's why I wrote 1 by tau. What is hgp of z? hgp of z equal to already. What is h of s? 1 minus e power minus ts divided by s. S only we brought here. The remaining thing is 1 minus z power minus 1. Therefore, HGP of Z equal to 1 minus Z power minus 1 multiplied by 1 minus e power minus 1 by 3. Because what we assumed, G of S equal to 1 upon 3S plus 1. 1 by 3 multiplied by Z power minus 1 whole divided by 1 minus Z power minus 1 multiplied by 1 minus e power 1 by 3 Z power minus 1. So these two getting cancelled. These two getting cancelled. Therefore, HGP of Z equal to 1 minus e power minus 0.33 is 0.716 Z power minus 1 whole divided by 0.716 1 minus 0.716 Z power minus 1. This is HGP of Z. HGP of Z equal to 1 minus 0.716 is 0.283 Z power minus 1 whole divided by 1 minus 0.716 Z power minus 1. This is HGP of Z. Therefore, D of Z equal to what? Digital controller D of Z equal to 1 by HGP of Z. We are assuming that first order system. That's why Y of Z divided by Y set point of Z is Z power minus 1 whole divided by 1 minus Z power minus 1. HGP of Z equal to what? Just now we found 1 minus 0.716 Z power minus 1 whole divided by 0.283 Z power minus 1. The numerator is Z power minus 1. The denominator 1 minus Z power minus 1. That is equal to Z power minus 1 minus 0.716 Z power minus 2 whole divided by 0.283 Z power minus 1 minus 0.283 Z power minus 2. This is the digital controller. If you write this way, this will be convenient to convert into time domain. For that, it will be useful. You can enter like that also. How to convert this into time domain? Cross multiply. Z power minus 1 means, if you convert this into time domain, Z power minus 1 means D of K minus 1. 1 means D of K. This is D of K minus 2. 0.71 is D of K minus 1. But D of K minus 1 equal to E of M of K controller output divided by E of K means, if you cross multiply, you can write like this. M of K upon E of K. Suppose you are giving error as input to the controller. Controller output is M of K. That is Z power minus 1 minus 0.716 Z power minus 2 upon 0.283 Z power minus 1 minus 0.283 Z power minus 2. If you cross multiply, you will get M of K minus 1. We can take this 0.283 outside. M of K minus 1 minus M of K minus 2 equal to 1 by 0.283 multiplied by, if you bring that E of K this side, you will get E of K minus 1 minus 0.716 E of K minus 2. If you shift by one sampling period, you will get M of K equal to M of K minus M of K minus 1 equal to 1 by 0.283 E of K present error minus 0.716 E of K minus 1. So this is why I am telling this is what is the controller output? M of K is the present controller output equal to, you bring this to the right hand side. You bring this to the right hand side. If you bring this to the right hand side in plus sign, what is controller output? Present controller output equal to previous controller output plus 1 by 283 times present error minus 0.716 times divided by 0.283 previous error. previous sample instant error. Like that, we can find the controller output. This is to understand what is d of z. But in simulation, you can enter this value directly. But you have to convert this into positive coefficients. So multiply on both sides z power plus 2, you will get 1, z power 1 minus 0.716 whole divided by, here also you multiply by z power 2, you will get 0.283 z minus 0.283. That's all. This is the controller in positive powers. Z minus 0.716 divided by 0.283 Z minus 0.283. So the controller is d of Z we got. D of Z equal to Z minus 0.716 upon 0.283 Z minus 0.283. This is the digital controller for deadbeat controller for 1 upon 3s plus 1 transfer function. Let us simulate and check whether it is working or not. Let us check. So the transfer function is 1 upon 3s plus 1. The digital controller we found is 1 minus 0.716. Coefficient of numerator is entered. We have to select a discrete transfer function. In that, you have to enter denominator is 0.283 minus 0.28. Coefficients we entered. So that's all about digital controller. We put this is the zero order hold circuit. This is the hold circuit because it is in Z domain, it is in S domain. So between these two, zero order hold circuit must be there. If you simulate this is for step change. So we gave a step change in the input, but the response is after one sampling period it is settled. What way we designed? We are expecting the response should be 1 after one sampling period. The response must be 1 after one sampling period. That is correct only. No, it is settled at 1. So what we designed is after one sampling period, the response must be 1. It is there. You understand this? So we'll see more about deadbeat controller in the next class.